Is Andrew Silva. And Andrew, I think he just waved. Andrew, I have a little bit of bio I can tell you about him. He actually attended 5 different community colleges, and Cabrillo was one of them before he transferred to San Jose State University to finish his degree. And he focused on robotics and controls, and he worked on a joint project with the Moss Landing Marine Lab to build a deployable instrument. After graduation, started working at Amaris, I think is how to say
Yeah,
it, but you can correct me,
that's it.
as a part of their automation team to develop tools and robotic workflows for synthetic biology. And he's just started working at a startup that's working on fusion energy, and we're so excited to have him here. So, Andrew, thank you for being here. Please, go ahead. I know you have some slides and
Yeah, of course. Hi, everybody. It's a pleasure to meet you guys. Thank you, Pretty, for introducing me. It's a pleasure to be here. As you guys will come to learn in your engineering careers, being able to communicate is a huge part of promoting your designs, promoting yourself, um, getting ideas across. So as much as I love to be here and sit with you guys and give back to Cabrillo College, where I did graduate from, I do actually benefit as well from getting exposure to talking and presenting and develop my communication skills. So just something to keep in mind when you guys are done and graduated is to stay sharp on your ability to get ideas across and to present yourself really. Um, I didn't come super prepared. I've been working like 12-hour days lately at the startup. It's been very exciting. There's not a ton I can disclose to you guys about the new job, but I can tell a few things, and I'd love to talk about the previous stuff. Um, to kind of figure out what to focus on, I'd love to hear what you guys are interested in and what paths you guys are interested in pursuing. If you guys are mostly mechanical engineering students, or if you guys haven't quite picked your set disciplines yet, or if anybody's interested in any like licenses for either construction licenses, mechanical like licenses, electricians, you can get your professional engineering license and be a principal engineer later on
why
after.
don't we have them type into the chat what they're interested in
Yeah,
so that we
please.
have an idea. So we'll
And then
start
I'll
with
start
that.
sharing my screen.
Okay. So we have one student, mechatronics. Everyone, if you don't know, go ahead and say I don't know. But computer engineering, mechanical, civil, ocean, leaning towards mechanical, mechanical specifically quality assurance, mechanical and ocean engineering, biomedical. Lots of mechanicals actually. So they're in the right place.
Yeah, so that's great. I did mechanical at San Jose State. Um, my emphasis on robotics and controls was very similar to what you would do in mechatronics. You do a fair amount of mechatronics um, in robotics and controls. It's kind of based in that field. What I will say is that mechanical tends to be the most base layer for a lot of the other engineering. And so you kind of, if you have a really good mechanical framework and grounding in the way you think and the way you approach problems, you can really pivot to any of these other engineering disciplines very easily and do really good work there just because you have a really solid foundation in the base principles of how we interact with the world and how we interact with these systems and then how we design these systems. Let's see if I can get this in present mode. Did somebody say they're interested in the ocean?
Ocean engineering, yeah.
Yeah, that's awesome. So I was really interested in that as well. I still am. I love the ocean. Um, I did some work with the Moss Island Marine Lab, and I was hoping it would lead to a career either there or at the Monterey Bay Aquatic Research Institute. Um, I uh, I did actually interview with MBARI, geez, maybe a year and a half ago, and I was unfortunately overqualified for the role, and they didn't want to hire me because they felt they would lose me in a few years. Um, which was unfortunate, but it really kind of showed me where I was at in my career. Because when I was in school and I was uh, set to graduate, I was really aiming for that job there, and I was doing everything I could to communicate with the people there and find a role. And the way that they hire is really slow, so it was good that I had taken like years to aim at that. And by the time it came around to hiring, it was too late for me, unfortunately. But it has led me to a job that I'm very energized by, and I'm sure it'll lead to more. But yeah, just know that the base layer of mechanical engineering will help with any of those things, especially the base coursework. I know the math sucks, or sorry, I know the math is very challenging. I know the physics is also very challenging, and it builds upon the math, but you will use those things. I know a lot of people joke that, when are they going to use geometry later in life, and when are they going to use calculus later in life? And if you get a job in engineering, you are for sure using that stuff. And it's it's good to know it through and through because it's harder to learn it when you're trying to use it in the workplace. Um, so definitely do your diligence now, because now's the time to learn it, and later on you have to apply it. But yeah, let me run you guys through just a little work sample I put together. Um, can you guys see the Zoom screen? Is that
Yep,
being
we can
shared?
see
Okay,
it
let me
says
try to hide that.
portfolio. We've got it.
There we go. Okay. So this is going to contain a fair amount of work from the last 7 years of my life. It's focused on a few projects. We're going to start with some work I did at Amherst. I'm under NDA still. Those are for life, typically. And I can't disclose a lot of the secret sauce behind some of these things, but I can do an overview and I can show you kind of the stuff that I worked on. Um, this here is a picture of an integration system that I designed for them. This is automating a benchtop assay that they would usually use humans to do. And so to increase throughput and arguably to increase accuracy, you automate these things. And so in yellow, you can see the reach of the arm. Um, Within that yellow, you can see various instruments. This is a plate sealer up here. Here's your arm and the work window. Uh, this device here and this device here are custom liquid dispensers that we built, and they're very accurate for the volumes at which they dispense. For preparing chemical assays and whatnot, you have to be, geez, I can't remember the units right now. It's nanoliters, but you have to be accurate within a percentage of what you're trying to hit. Otherwise, your chemistry is off, and you're not going to be able to do either the spectroscopy you're trying to measure or the reaction you're trying to measure. So this is just a table we put together to automate some workflows. Um, and from like an engineering point of view, you're dealing with liquid fluid dynamics, you're dealing with electricity, you're dealing with programming a few of these things, and you're programming them at various levels. Um, you're programming the firmware on the controller for the motors, you're programming the network adapter card so you can communicate to the thing, and then you're writing like an actual application so that a normal person can walk up and use this thing. And they don't see those layers underneath. But you guys will, and you guys will eventually be thinking like that when you approach stuff like this. Um, this was another job I did at Amorous. They had some trays that they wanted to duplicate, and they had some documentation. And they had tried to do this before my tenure there, and they had been unable to do it. And so when I came aboard, they put this in my lap. My background as a machinist allowed me to tackle this pretty readily. What I did was I first documented it. I found out that their documentation was incorrect, and so I drew what's called an as is or as built documentation. And then I was able to replicate it and document the correct procedure so that when they made these trays, they could make them again and again, instead of having to send them out and pay way more money than they needed to make these modifications. And these are just shaker trays. I should have put another picture of what these go into, but these go into these huge environmental chambers. They're like this big, maybe that tall. They hold a certain humidity and they hold a certain temperature, and they can shake at a set speed to agitate cells. We use these for culturing cells between workflows. So Amyris, I should have covered this earlier. Amyris does synthetic biology, in which they're using technologies such as CRISPR or mutagenesis to force evolution or engineer evolution into yeast cells. With those yeast cells, they feed them in what's called a bioreactor. So after they get a strain of yeast that they're confident is going to make what they want, they put it in a bioreactor, they feed it. The yeast eats the feed, which is typically just corn syrup or sugar mixed with water. And then the yeast byproducts compound that they're interested in, that they have engineered the yeast to make, and as well as some effluent, some waste. Um, an example of these products that they've gotten yeast to make is a bunch of healthcare stuff more recently. Originally, they made artemisinin, which was is a treatment for malaria, I believe. And then they made biofuels, such as biodiesel and biogas. So they were making, they're able to make the same chemical composition as fossil fuels, just by feeding yeast sugar. And so they were kind of ahead of their time at the time. Fuel prices are now in the range that they would be profitable if they retooled, but with that takes away from their current R&D. So a lot of balances going on. But if you ever heard of brands such as JVN or Biossance, they were the company behind that stuff, and they made the compounds and molecules that were into these beauty products. Um, this is another tool designed for them. This is an integrated system that was going to automate the sampling of these bioreactors that they grew. So they have about 160 bioreactors. They're 5-liter bioreactors. And these are 20 milliliter sample vials. So what they wanted was a way to send these sample vials to each bioreactor, take a very known volume of sample, and then send that out to get analyzed through chemistry, as well as spectroscopy, just so they could tell what each strain was doing. Because as much as they have the ability to engineer these strains, um, they can't control finitely what the strains take. And so they have to screen, like when they make the edits, they can't control how much that edit gets in there. And so they have to grow a few variations, and by that I mean thousands of each strain, and then run it through tests and screen them to see which one's producing the molecules at the highest percentages that they can get. It's just gamifying production to see which strain has mutated in a way that is beneficial for the product they're trying to get. So this was an automated vial handling station that I designed for them. Um, this allowed operators to walk up, load this hopper device that I designed with up to 160 vials. The robotic arm would pick it up from the hopper. It would take the cap off with this decapper here, and it would then label it so that it would barcode it, and it would automatically put it in their database system so they knew what vial had what sample and was getting sent where. In the middle of the table is some uh, shake tables, as well as some heating blocks for incubation of these samples. And there's a rack here for caps. Um, this is the recapper that I designed for them. This device was pneumatically driven as well as electrically, but the pneumatics would open and close the grabber, and then the electronic motor would spin it forward and reverse. This was just for unscrewing the vials from the caps and then putting the caps back on them. This was like the initial project they hired me for. So this was like one of the first things I designed out of college in my career. And I had the time to be careful about it. And it worked right out of the bat, and I was really proud of that. And they still use it. You can see me initializing the motor controller here. So I had it apart. I had to give it an IP address. I had to configure how much drive to give, what amperage to run it at, how fast I want this thing to run. Some sample of the code that we used. to control it. At the corporate level, they were using C Sharp for a lot of our internal controls. I worked with a bunch of data scientists, and they had the privilege of using Python. Unfortunately, I've come to learn that Python's great for programming, but if you're running in the world of robotics and embedded systems, um, you want to learn C++ and you want to learn C Sharp, and you have to use the more refined tools because otherwise you're using 3 times as much computing power. And if you're iterating these and you're making products, it's really hard to justify a 3 times as expensive computer for a product when you're making a bunch of them. So if you can learn a language, learn any of them. They're all great, but at some point you have to learn the language that's mostly geared towards what you're most interested in. And I did learn Python, and I do still use it, but I've come to find that I was most interested in the things that run C Sharp and C++. And so I had to learn it. And now that I've learned it, and this is something I really want to instill, is find the thing you're interested in, get good at it, and then leverage it. Because if you like doing it and you're good at it, you'll have no problem leveraging that thing. And while I'm saying that, take on any responsibility that your employer is going to put on your plate. Um, I would never say no to work at my jobs, and I don't want you to think that that means I'm a pushover. I just knew that when the time came for me to ask for money, if I had the most responsibility on my team, I had all the leverage. And so Amherst downsized from a 1,700 person company to less than 150 people. So we did an order of magnitude worth of firing, and I was still there at the end. And when I left, they tried to offer me even more money to stay, and I would not because I just wasn't interested. But that was because I never said no to responsibilities, and I just took anything on that they wanted me to. Uh, so it wasn't easy, but it wasn't too much work either. Like I had a life up until the recent job. I had a life anyways. So this is the vial dispenser. This is a thing that an operator could walk up to and put 150 vials on. It would auger them into this corner. This is an interrupt sensor. It would sense when the vials hit there and trigger the system to know that there's a vial waiting to be picked up. My first revision had this very straight fence, which did cause a jam in some edge cases. And so we refined it to this more uh, natural looking bend, um, compound radiuses instead of just one angle. And that never jammed. It worked great for us. Um, excuse me. As far as I know, they're still using it today. This is the control program for it. This is just a really basic driver, basically. This just exposes the command set that the motor controller uses to the higher level program in which um, you write a higher level program for the operator to interact with. That higher level program interacts with this driver and then controls the actual physical thing.
Andrew, I want to leave time for our students to ask you some questions. Did you want to talk about some of your more recent work?
Yeah. So recently at the fusion company, Jupiter Volta, I've designed a process cooling water skid. I've done a ton of programming and wiring. Um, and we're a very small company. We all wear a lot of hats. The exciting thing I can share about Jupiter Volta that isn't under NDA is that while we're doing plasma physics, we're not using any magnets or electromagnets. And so that's like a little hint at why we feel that we are the unique solution to fusion energy. Um, our control package requires orders of magnitude less energy, and so hitting a break-even point should be much easier for us. But yeah, please ask any questions. These are just pictures of when I was a machinist. This is the project we did with the Moss Landing Marine Lab. I'd really like to answer you guys' questions and hear what you guys are interested in and where you guys want to go with your careers.
I'm gonna start it off, and then maybe they can chime in the chat or unmute. But seems like you've worked at three very different companies. What, how would you compare and contrast that experience?
Yeah, absolutely. So while I was in school, I worked as a machinist. It was a very small company, um, and I played a big role there. And it was good to be a big fish in a small pond. Although small ponds don't have a lot of resources. And so when I graduated, I was very keen to find a engineering role. Machining in America isn't, what it used to be. And so 6 months before graduation of college, I started applying for jobs and I landed a few. Personally, I chose to stay near my family. I didn't want to move too far, but there's a lot of opportunities everywhere, and it's worth considering moving for. When I went to Amherst, I was definitely a small fish in a big pond, and I had to learn very quickly how to swim, how to navigate corporate kind of cultures, um, and I had to learn how to navigate a lot of different personalities. I found quickly that I was kind of unbeknownst to me, stepping on the toes of the other mechanical engineer on my team. Um, he felt threatened by me um, because of my competency, and I did not pick up on that until he finally just had a talk with me about it. Um, but yeah, working in big companies, you're going to meet a lot of personalities, and sometimes people lose sight of the goal and make things about them that really shouldn't be. And so I've been guilty of that as well. And so it's just good to try to keep yourself grounded and look out for everybody, including yourself.
Good
Um,
advice.
moving
Um,
into a startup, um, on that note, I had to look out for myself in the negotiations. Um, it's it's different getting paid equity from a startup than it is getting paid equity from a big corporation. And so you got to do your due diligence on compensation. You got to really look into the weeds on how you're going to afford the opportunities that they're giving you. Um, for me, Amherst was giving me small equity granted. They're called RSUs. And so you just at your year anniversary, you get a set amount. At your 2 year anniversary, you get more. At the startup, we get the opportunity to buy shares at a fixed price. And so to get the equity, I have to pay for it. And I had to do the math on how I was going to be able to afford to pay for that opportunity. And so it wasn't as easy to accept that offer as it would have been elsewhere.
but it sounds like it's an investment in yourself.
Yeah, and it's exciting. You get to a point where you're not scared about losing your job and and you can take on more risk. And so I was finally at that place. I had started an LLC last year just to do consulting for outside corporations. Um, and so I was confident that if I lost my job, I could float myself. And so that freed me up to pursue um, the fusion company um, and really focus on what I was passionate about instead of like what I was just interested in.
Sure. And then you also said that you went to a variety of community colleges and actually two undergraduate institutions. Can you impart on the students something that you took away from that experience? Since they're at Cabrillo, was there anything specific that Cabrillo that you would recommend that was really unique to Cabrillo, something like that?
Yeah, absolutely. The community at Cabrillo is really welcoming and nice. I don't know if Carlos Figueroa is still there, but
Yes.
he was an amazing professor. I will never forget taking his classes. Um, so I know the staff there is just fantastic. Um, it's a wonderful place to be. So wonderful places to be really attract high quality people. And yeah, they are doing good stuff there. I went to 5 community colleges and I chose to graduate from Cabrillo. It was the right choice for me, and I would do it again in a heartbeat.
Are you still in the area? Is um
I'm in the East Bay now, so I'm in like Oakland, Richmond area.
oh, okay. Okay, cool.
Yeah.
Yeah. So in the chat we have a few questions. I feel like some of them you've answered, but maybe if you want to touch on anything more, I'll just read them off to you.
Oh, sure.
How often are you using computers as a mechanical engineer? But I thought you showed that. What type of physical constraints did you have to develop around while building projects like the vial uncapper? Are there
Yeah.
any large differences between the startups and the larger corporations besides equity?
Mhm.
And how do you get into the field of nuclear fusion, which is a part of nuclear engineering, but that wasn't your degree. So these are some
Right.
interesting questions.
Right. And that's why I'm kind of a proponent for mechanical. It's a bit of a base layer for all those other engineering degrees, especially if they are physically based. And a lot of overlap between the two. I use computers every day. Um, I do a ton of computer-aided design. I do a fair amount of programming. Um, for programming, there's great advancements going on in AI right now that make you a lot faster than you could be otherwise, and definitely like smarter, I guess I would say. Um, but yeah, definitely get comfortable with computers. I've come to learn that when you're doing mechatronics and robotics, you have to be a bit of an IT person. You're eventually going to be debugging networks and trying to talk to a machine on a different network, and your IT person is just not going to know because they don't live in the world of embedded computers. They don't really talk to robotic arms very often. So you're probably going to have to be your own IT advocate, and that's okay. You're going to be fine. Um, but yeah, just know that computers aren't going away, and we're gonna have to use them and be good at them. Just makes it a lot easier. I've regretted that my organization on my computers isn't as good as it could be. Um, so if you can get well organized on a computer and stay that way, it's probably a lot easier than trying to declutter your computer later in life. Anyways, physical constraints, physical and electrical, mechanical constraints. Constraints are good. Um, in the early stages of scoping a project, get as many constraints as you can. Um, you'll know which constraints are actual and which constraints from like the operators or the scientists you're working with are nice to haves. And for the actual ones, those you're gonna have to design around them, and that's good because you want limitations. It makes it easier to design. Um, I know it's not intuitive, but I promise you you'll figure that out. Um, when it comes to other people's desires and you see those as constraints, just review them often. Anytime someone has a nice to have, review it often because eventually either the cost is going to throw it out or the need for it is going to justify the cost. And it's it's never really your money at these companies, so you gotta pick a lane and decide, hey, this person wanted it, but you guys have to verify that you want it and that you guys are going to pay for it anyways.
Yep. It's all about the customer, right? We've talked
Yeah,
about
and
that in
your
this class.
customer is typically your boss or
Yep.
the scientist that you're working with, or you could work at a company that does sell products, and then your customer is whoever buys it, and that's even more to concern yourself with.
Yeah. So we have to say thank you to you for coming because
Yeah, of
our
course.
next speaker is here.
Awesome.
So thank you so much, Andrew, for sharing with us your experience and the work you're doing. I think you've inspired a bunch of the students in the class. So cool.
Yeah, great. I'm glad to be here. Ask your professor for my email if you guys have any questions. I'd love to help out anybody starting out. And just thanks for letting me attend and share my time with you guys. Sorry if I
Awesome.
rambled a bunch. It's been a long Monday.
All right. Well, good luck with the new job. Thanks for sharing.
Thank you guys.
All right.